Okay, class, today we're going to actually start the last chapter of our textbook. We're on chapter 12, and we're back to quadratic equations. Now, we spent a lot of time with quadratic equations back in chapter 5. Chapter 5, we learned how to solve quadratic equations by factoring, x factor, our good friend. In chapter 11, we learned how to solve quadratic equations if they were x squared equals k, and that's where this comes from. And here our k is going to be a perfect square. Now we're going to see when k is a perfect square, we got three different scenarios. The first scenario is if k is positive. Well, let me give you an example. If I said x squared equals 16 and I wanted you to solve for x, well, you and I know we've got to take the square root of both sides to go from x squared to x. So we would have x equals plus or minus 4. And so we're going to see when k is positive, if what's inside the radical is a positive number, then I'm going to have two real number solutions. If, on the other hand, k is 0, if what I have inside the radical is 0, then it has one real number solution because the square root of 0 is 0. So let's say I had x squared plus 9 equals 9. And we would have to subtract 9 from both sides. So we've got x squared equals 0. Well, if I take the square root of both sides, the square root of 0 is 0. So if k is 0, if the number in the radical is 0, then I have one real number solution, and that solution is 0. Now, the new one for today, big red star by it, is what happens if what we have inside the radical, if k is negative. Well, we're going to see if k is negative, there's no real number solutions. Kind of looks like this. Let's say that I gave you this equation to solve. Let's say I said, let's do x squared plus 25 equals 0. Well, we've got to isolate the variable. If we get x squared alone, we're going to subtract 25 to the other side, and then we're going to have to take the square root. So we're going to get x equals plus or minus the square root of negative 25. Well, if you look inside the radical, it's a negative number, and I can't have a negative number inside the radical, so therefore it is no solution. So we've got to kind of watch for that as we're going through and solving all these different equations. So let's see what that looks like for you and I. So if we look at the first one, and we're going to solve for x. Remember, actually we're solving for y, and y is in the parentheses squared. So the first thing I need to do is get rid of the parentheses squared. So the inverse of that, we've already learned that the opposite of squaring something is taking the square root. What I do to one side, I do to the other. So now this is y minus 7 equals, and the square root of 0 is 0. If we add 7 to the other side, we're going to get y equals 7. Now, if we happen to go through and check that, we would pull that in there, and we would get 7 minus 7 squared equals 0. 0 squared equals 0. So it works nicely. Now, look at number 2. If I'm looking at number 2, I've got a squared equals negative 9. Well, I know I'm going to have to take the square root of both sides. Now, there it is. We've got a equals plus or minus the square root of negative 9. K, the number that's inside the radical, is negative. I can't take the square root of a negative number, so the answer to number 2 is no solution. All right, number 3. If I look at number 3, I've got to isolate the variable by inverse operations. So let's go ahead and divide both sides by 3. And we're going to get x squared equals, let's see, I think that's 36. Now I know I've got to take the square root of both sides. So we're going to get x equals plus or minus the square root of 36. 36 is a perfect square, so that means x equals plus or minus 6. And let's look at number 4. If we can get number 4, we've got to get m squared alone. So I'm going to add 54 to the other side. So m squared equals 54. Once again, I'm going to have to take the square root of both sides. So we have m equals plus or minus the square root of 54. Now this time 54 is not a perfect square, but you and I know how to simplify a radical. If I simplify that radical, well, we know it's going to have to be what? 9 times 6. So we're going to get m equals plus or minus 3 root 6. Okay, so if you notice, we've only got a quadratic equation where it's x squared equals k. Now let's take it a little bit further. What's going to happen on number 5? Well, if I look at number 5, again, I'm solving for x. X is inside the parentheses squared, so I've got to get it out of the parentheses squared. So we're going to have to take the square root of both sides. So that means I've got x plus 6 equals plus or minus 4, because the square root of 16 could be positive 4 or negative 4. And now I need to get x alone. And in order for me to get x alone, I've got to subtract 6 to both sides. So we're going to have x equals negative 6 plus or minus 4. Now here's where it gets interesting. I actually have two whole real number solutions. We're going to say x equals, and if I said negative 6 plus 4, I would get negative 2. And now I've got to do the subtraction part of it, and we've got negative 6 minus 4, which is negative 10. And again, that's no surprise that we have two answers, because x squared means I need to find two x's. Now, if we're looking at number 6, hopefully we realize we got to divide both sides by 6. So I've got z plus 5 squared, and 42 divided by 6 is 7. Square root both sides to get that parentheses square gone. So we've got x plus 5 equals plus or minus 7. Now, how am I going to get z alone? Well, I've got to subtract 5 from both sides. So we're going to get z equals negative 5, whoops, Mrs. Burton forgot something, plus or minus the square root of 7. I forgot to take the square root of 7 over here. All right, now, negative 5 plus or minus 7, believe it or not, is your final answer. I can't put them together, in the house, out of the house. Okay, they're adding and subtracting. They're not like radicals. So that is your final answer. Now, sometimes you'll look in the back in the book and they'll give you two different decimals, but we're going to leave it in radical form. Now, look at number 7. This one's a little tricky if you don't recognize something right away, and I gave you a hint. It says, are both sides perfect squares? And if you notice, they are. And this goes back to chapter 5, where we learned how to recognize a binomial squared. If I use my good friend x factor here, I would find that this is going to be x minus 7 squared equals 64. Okay, now a little time out here. If we went ahead and we x factored, okay, now some of you might have recognized the pattern, but we would do x and x. If I look at our signs, they're both minus. We're going to use 7 and 7 for 49. We would use our little x factor friend, and we would see that we had chosen wisely. So we can take this and write it like that. Now we're back to where we were on the previous slides. I need to get x alone out of the parentheses squared, so we take the square root of both sides. So x minus 7 equals plus or minus 8. 64 is a perfect square. And now we're going to add 7 to both sides. Now, here's what's going to happen. It's going to be x equals 7 plus 8, which is 15. Or it could be 7 minus 8, which means x is going to equal negative 1. Can you look at number 8 and tell me what my binomial squared will be? Remember, this is a perfect square, so we say y squared minus perfect square there is 9. And then it's parentheses squared. So parentheses squared equals 144. Okay, I've got to take the square root of both sides to get rid of that parenthesis squared to get y alone. So y minus 9 equals plus or minus 12. 144 is a perfect square. We're going to add 9 to both sides. So we've got 9 plus or minus 12. So y is going to equal 9 plus 12, which is 21. Or it could be y minus 12, 9 minus 12, which would be negative 3. Okay, so we're moving along at a pretty good clip here. Let's look at number 9, fractions in the house. Okay, so let's check it out. What would we do? Well, the first thing I would do, because it's t squared, I got to make it equal 0. So I'm going to go ahead and have 1/4 t, and I'm going to add 9 over 64. Now, how do I get rid of that 1/4? Yeah, you're right. Oh, Mrs. Burton forgot the t squared again. So let's put t squared. Okay, I got to multiply both sides by 4. That's how I get rid of that 1/4. So we're going to have t squared equals, and if I multiply both sides by 4, what's going to happen? Well, this is going to be times 4 over 1. So 9 times 4, we got 36 over 64. Now, I know it's a fraction, but did you notice they're both perfect squares? So if I take the square root of t squared and the square root over there, we're going to get t equals plus or minus. And we've got the square root of the numerator over the square root of the denominator. So we're going to get plus or minus, and we're going to get let's see, square root of 36 is 6, square root of 64 is 8, and then make sure you reduce your fraction. So it's going to ultimately be plus or minus 3/4, and that's your final answer. All right, we're going to skip number 10 for now, and let's go over here and look at number 11. Let's look at number 11. Now, solve by factoring. Okay, a little bit different. They want us to go through and factor here like we did back in chapter 5. Hey, do you remember what's the first rule of factoring? Yeah, that GCF. So if you look, we're going to factor out a 7, but what else can I factor out? That's right, I can factor out a y, and I'm left with y squared minus 4 equals 0. Look inside the parentheses. Have we factored completely? No, that's difference of perfect squares. So now I've got y plus 2. Remember, difference of perfect squares becomes sum and difference. And now zero product property. If the whole thing equals 0, each part equals 0. So 7y equals 0. And we divide by 7, so y equals 0. If y plus 2 equals 0, we're going to subtract 2 to both sides, so y equals negative 2. And if y minus 2 equals 0, we're going to add 2 to both sides, y equals 2. And that's my answers. And of course, we have 3 answers because we had y cubed, so we need 3 answers. Okay, now let's look at the last problem here, number 12. I've got some fluff, so let's divide both sides by 3. So now I have 5x minus 2 squared equals 27 divided is 9. We're going to have to take the square root of both sides. So I've got 5x minus 2 equals plus or minus 3. And we're going to have add 2 to both sides. So we got to get x alone. So 5x equals 2 plus or minus 3. And now we got to divide both sides by 5. Now this looks kind of weird. You could say x equals 2 plus or minus 3 over 5. So that means x could equal 2 plus 3 is 5 over 5, which is 1. Or we could say 2 minus 3 is negative 1/5. So those are my 2 answers for the last problem.